lesson G, the relationship between lines. So when you have two lines, there's a few different things that can happen between them. Two lines can be parallel, okay? If you want to check to see if two lines are parallel, what you want to do is you want to compare the ratio of the direction vectors. All right, and we'll do an example in a moment so you see. Now, if two lines intersect, right? If they intersect, you're going to have a single common point, okay? Now, if they intersect, they might also be perpendicular. In order to test perpendicular, remember we use the dot product, right? Now, if two lines are not parallel and they're not intersecting, then they must be skew, okay? Then they must be skew. There's another type of line. They call it coincident. Coincident, right, are just two lines that are exactly the same line. So if you have one line, right, and if the second line is exactly the same, right, then we say the lines are coincident. All right. All right, so let's take a look at this example here. We want to show that lines 2 and 3 intersect, and then we need to find the angle between them. So lines 2 and 3, so what I'm going to do is I'm going to take the x and set them equal to each other, right? So 1 minus t is going to equal 1 plus 2u. All right, and then we have t is equal to negative 1 minus u. And then we have 3 minus 2t is equal to 4 plus 3u. Now, we already know that t equals this, so I can do a direct substitution into here. So I can take this, plug it into here. So I get 1 minus parentheses negative 1 minus u is equal to 1 plus 2u. So I'm going to solve for u now. So 1 plus 1 plus u is equal to 1 plus 2u. So minus u here, so u is going to equal 1. Okay, so now that I know u equals 1, I can plug it in here to solve for t. So t is equal to negative 1 minus u, which is 1. So t is going to be negative 2. So now that I know what u and t is, I can plug them back into the lines, all right, line 2 and 3, to find the x, y, and z coordinates. Okay, so I'll do that. So for line 2 here, so I'll do it right here, line 2. So the x, y, and z. So all I'm doing is right here, line 2, I need to plug in the t, which I know is negative 2 now. So if I plug in negative 2 here, I'll get 1 minus negative 2. So it'll be 1 plus 2, so that'll give me 3. Over here, all right, t is going to be negative 2. And over here, if I plug in negative 2 over here, I'll get positive 4 plus 3, which would be 7. Right? And then for line 3, all right, I know the u is 1, so if I plug it in here for line 3, all right, 1 plus 2, that gives me 3. All right, I plug in the 1 here, negative 1 minus 1 is negative 2. Then I plug in the 1 here, 4 plus 3 gives me 7. Now you notice we have the same xyz and xyz for both lines. That means that the two lines cross. All right, what that means visually is the two lines cross. When they cross, they're crossing at these coordinates right here. The x is 3, the y is negative 2, and the z is 7. Okay, now we need to find the angle between the two lines. All right, so we need to find the angle between the two lines. What we care about are the direction vectors. Okay, so let's say A here is a direction vector for line 2. So in this case, it'll be negative 1, 1, negative 2. Let's say B is the direction vector for line 3, right? So that would be 2, negative 1, 3, right? So I'm just basically grabbing these coefficients right here, right? Now to find the angle between the two lines, all right, we have our equation, All right, so we have cosine inverse, and then we're going to have the dot product. And remember, we absolute value these. This means absolute value, right? So we have the dot product of these two direction vectors, and we absolute value that, so we're always going to take the positive of that. And then we take the magnitude of A and the magnitude of B, so we're dividing by the product of these magnitudes. So we're just going to work this out right here. So you work it all out. Absolute value, -2 plus -1 plus -6 divided by magnitude 1 plus 1 plus 4. We have 4 plus 1 plus 9. And then you work all this out, and then you're going to end up with theta. If you put in the calculator, you'll end up with 10.9 degrees. Okay. All right, so let's take a look at part B here. So part B, we want to show that line 1 and 3 are skew. Right? So lines 1 and 3, we want to show that they're skew. Well, if they're skew, that means they're not parallel and not intersecting. So first we're going to show that they're not parallel. Okay? So if they're not parallel, we want to show that the ratio of the direction vectors are not equal. So here's line 1 and 3. So here's the coefficient right here, 2. Coefficient 2, so we have 2 over 2. Is that equal to? And over here we have -2, right? -1, -2 over -1. And we don't even need to compare the third one, because if you just look here, these are not going to be equal. Over here we get 1, over here we get 2. So these are not equal already. So that means that the lines are not parallel. Okay? So if the lines are not parallel, now we want to show that they don't intersect. Right? So to show that they don't intersect, so I'm going to begin by setting the x's equal to each other right here. Right? -1 plus 2s is equal to 1 plus 2u. Then I'm going to do the same thing with the y's, and then also the z's. Right? So then the y's, I have 1 minus 2s is equal to -1 minus u. And then I have 1 plus 4s is equal to 4 plus 3u. Okay? Then I'm going to do some algebra, rearrange everything, get the u's and the s's on the same side. So I'll have 2s minus 2u is equal to 2. Up here, I have, let's see, this would be 2s minus u is equal to 2. And then over here, I would get 4s minus 3u is equal to 3. So now what I'm going to do is I'm going to take this equation and this equation and set up a system. Right? So I'm going to take this right here. So I have 2s minus u is equal to 2. Now it looks like it cancels out the s's. All right, so I'm going to multiply everything here by -1. So that would change the sign. Negative, positive, negative. So then these would cancel, and it would -u is equal to 0. So u is equal to 0. Now that I know u is equal to 0, I can just plug it in here to find out what s is. So I'm just going to end up with 2 is equal to 2s, so s is going to equal 1. So now that I know what u is, and I know what s is, I can plug them into lines 1 and 3 to find the coordinates. I'm going to plug them into lines 1 right, and line 3 to find the x, y, and z coordinates. So for line 1, I'm going to plug in s, right? S is 1, so I plug in 1 here, here, and here. So for line 1, x is going to equal 1, y is going to equal -1, and z is going to equal 5. And for line 3, all right, I plug in u, all right, which is 0 here, here, and here. So x is going to turn out to be 1, y is going to be -1, and z is going to be 4. Okay, so we've shown that the lines are not parallel. And now that the lines right here, we show the coordinates here, they are not the same, right? So since the coordinates are not the same, we know that the lines do not intersect, right? So if they're not parallel and also they don't intersect, right, that means that they must be skewed, right? All right, so lines 1 and 2 here, we want to show that the lines are parallel but not coincident. So to show that two lines are parallel, what we want to do is we want to show that the ratio of the direction vectors, right, are equal. So the coefficients here, right, in front of the variables, remember these give us the direction vectors, right? So we want to set up a ratio, right, between the coefficients of the x's. So we have positive 2 divided by negative 1. This should be equal to negative 2 divided by 1. And this has to be equal to 4 divided by negative 2. All right, so we have this and this right here. Now, if all of these are equal, that means the two lines are parallel. Right? If these are not equal, then the lines are not parallel. Right? So this gives us negative 2 equals negative 2 equals negative 2. Okay? So since all of these are equal, that means the lines must be parallel. Right? So we've shown that the lines are parallel. Now we need to show that they're not coincident, right? That they're not coincident. That means that they're different lines, right? They're not the same line. All right, so let's take a look at line 1 here, right? So for line 1, let's say s is equal to 0. If s is equal to 0, my x, y, and z, right? My x, y, and z would be, let's see, x would be negative 1, y would be 1, and z would be 1. Okay. Now for line 2, now if y is equal to 1 for line 1, right? Now you notice for line 2 here, y is equal, we need y to be equal to 1, so that means t would be equal to 1, right? So t would equal 1, that would make y equal to 1, so that these are the same, right? So now we plug in 1 for t into x and z to see what they are. So if I plug in 1 right here, 1 minus 1, so x would be 0. If I plug in 1 right here, 3 minus 2, so z would be 1, right? I get 0, 1, 1. So you notice these coordinates are not the same. So that means that these two lines must be different, right? So that means they cannot be, right? They are not coincident, meaning they are not the same line. If these are different, right, then these are not the same line. So we've shown that they're parallel because the ratio of the direction vectors are equal and the coordinates are different, so that they have to be different lines, so they are not coincident.